Hello Python programmers, this is AK. In this video we are going to learn about one of the important approaches in machine learning that is called ensemble learning. I already shared this information in the previous video, like I will post a next video about ensemble learning, and I gave an overview explanation about the ensemble method in that video. So if you haven't watched that video, I will give you the explanation of ensemble learning one more time. Okay, so ensemble learning is nothing but combining the multiple machine learning models to produce better outcomes. So this is called the ensemble learning. Suppose if you are going to buy a car, definitely you will ask some suggestions to your family members or friends. So this is the approach followed in ensemble learning. After collecting those informations from your sources, you take the right and accurate decisions. So this is what the ensemble learning is. In the machine learning, the ensemble is a very huge topic to discuss. It is not a very easy task to explain whole ensemble methods in a single video. That's why in this video we are going to discuss one particular method from ensemble group, which is called voting classifier. First of all, the ensemble techniques are divided into three categories. The first one is bagging, and second one is boosting, and final one is stacking. Now we are in the voting classifier. In this video we are going to discuss the voting classifier more detail from the bagging category. Before starting this video, do like, share, comment and subscribe. These things will help me to motivate and it will bring you more new contents in Python and data science. So let's get started. Bagging is one of the primary approach in machine learning. So how it will works? Suppose if you have large data set and you want to implement the bagging classifier in that data set for increasing the accuracy means, like when you feed the data set into bagging classifier, first of all it splits the data set into subsets and it will implement the algorithms that you define in your code. After it gets trained with multiple algorithms, it will aggregate all the results and it will provide the results from the single model. So this is the approach of bagging classifier in machine learning. In overall bagging classifiers, we picked up one technique called voting classifier for the explanation purpose. So the name voting classifier itself saying that based on the votes of different models, it will choose the output results. So just keep this one line with you. I will explain more precisely when we try to implement in coding part. At that time, you can understand more about this. Okay. So in this video, I don't want to waste the time on theoretical explanation. I will show you the proof of how ensemble learning improves the model accuracy. For this explanation purpose, I used one dataset called diabetes dataset. This dataset is not new for me. I already did a logistic regression video on this dataset. The advantage of using this dataset is it is very cleaned and it has no categorical feature. If any categorical features are there means we have to write a code for converting the categorical into numerical features. So I am very lazy to do that step. So only I choose this dataset. Okay. After importing all the libraries, now I am going to allocate the features from this dataset. Here I declared two variables x and y. X variable contains all the features which are important and y variable contains our outcomes. After the feature allocation part, I am going to split this dataset into two parts. One is for training and another one is for testing. For testing our model, I allocated only 30% of data from the dataset and remaining 70% will go for the training purpose. After splitting the dataset, I am going to train the dataset with three algorithms. All are classification algorithms. The first one is the Gaussian naive-Bayes classifier and second one is the decision tree classifier and third one is the logistic regression. So I am expecting these algorithms will perform good on this dataset because this dataset is not that much complex one. So the model here will give you the good accuracy from initial process itself. And the next step is I created one variable called a classifier and I put all the model objects parameters in this list. So it is very easy for you to understand and evaluate the model performances when you put this in the list object. So after this process, I'm going to create a new data frame called prediction df. Why I'm creating this data frame means in this data frame, I'm going to create a new column called action. So this action column will hold my y-test feature. Y-test is nothing but it is our original results from the dataset. And by using the original results, I'm going to compare with the results of these models. So this is the concept I'm trying to implement. So look at this. I created a new data frame and in the action column, I assigned y-test. So next thing I'm going to start my prediction by using these three different algorithms. So let's check how much accuracy this algorithm which brings. So look at this. These are the accuracy that I got without using voting classifiers. Among these accuracies from the model, I need to select the best algorithm. I already told you I'm going to compare my original dataset results with other model results. For viewing the results of models, you have to print the predictions df data frame. Now see the results of predictions. The action column that contains the original dataset output values and rest of 3 are the predicted values. Okay, so with these data frames, we can judge the model performances. So we can use voting classifiers here to predict which model is a good for classification based on the accuracy metrics. So let's implement the voting classifier technique on this dataset. Now look at my code. By seeing the code itself, you can easily understand what I did. First, I called the voting classifier model and then I created 3 variables which are loaded with our classifiers. And I wrote the code for the prediction. So let's run this program and we will see what are the output that the program brings. So these are the predictions that this voting classifier did with the help of these 3 algorithms. But here the predictions are not important. We want to know the accuracy of this machine learning classifier, right? So in voting classifier, there are 2 types of votings are there. The first one is the hard voting and second one is the soft voting. So you can see in my code for prediction I used the hard voting method. So let me explain what is hard voting and soft voting. After that we will go for the accuracy of this voting classifier. Okay. The first one is a hard voting. Hard voting classifier classifies input data based on the mode of all predictions made by different classifiers. The majority voting is considered as final outcome. So this is the concept behind the hard voting classifier. And another thing is the soft voting classifier. Soft voting classifier classifies the input data based on the probabilities of all the predictions made by different classifiers. So in this image you can see the models are providing some percentages. So based on the probabilities of those, we are picking up the model. So by seeing this image itself, you can easily understand what I am trying to say. So there is no need for much deeper explanation about the soft voting classifier. These 2 images will help you to understand everything about the hard voting and soft voting classifiers. Okay. Now it's a time for checking the accuracy of individual model performances in voting classifier. Look at my code. I'm going to run this cell for checking the cross validation score of each and every model after we implemented in voting classifier. So you can see that all the accuracies are increased after the implementation of Ensemble voting classifier. So this is the power of Ensemble learning approach. Most of the data scientists and machine learning people call this approach as a winning strategy because it will improve the machine learning model more higher and it will save the training time, memory of each and every computer. So this is what the Ensemble learning is, and if you like these experimental videos in machine learning, then support this channel. It will motivate me to produce more useful content like this in Python and data science. So thanks for watching and thank you and see you on next week.